Is that weird?
Yeah, so why is that?
That's right. Why is that?
Instead of the two vertical bands that you'd expect, a series of vertical smudges appear. To make sense of this pattern, you need to look at it from the perspective of a single photon. This photon is landing in a place on the back wall that would be physically impossible if it were travelling straight through just one of the slits. So, the only explanation is that the particle has gone through both slits simultaneously. By the time it reaches the back wall, it has come together again as one photon. Multiply this single photon 1,000-fold, and you have the distinctive pattern that Mark saw. Think about it. A photon arrives at the slits in a hell of a quantum state and travels through both. A single object is in two places at once.
Now you're blowing my mind.
Good. That's our job to do, to blow people's mind. So make you think, right?
Whew, my brain hurts.
Okay.
I wish I was back home playing my guitar.
And it's not just photons that behave like this. The double slit experiment has been replicated with electrons and with atoms. But we are made up of atoms. So, atoms can be in two places at the same time. Why can't we? One man thought he had the answer, the godfather of quantum mechanics, Niels Bohr. He'd won the Nobel Prize for his research into the atom. During World War II, Bohr escaped the Nazis and ended up helping the Allies develop the first atomic bomb. In 1954, he visited Princeton. While there, he gave a lecture to the students. By this time, Bohr had overthrown Einstein as the giant of the physics world. For a student to challenge him, he'd have to be very naive or very arrogant. It could be argued that Hugh Everett was both.
Oh, yeah.
Yeah, that's me, and Theo, and this is Niels Bohr.
This photograph was taken just before Bohr's lecture. The other men pictured are Hugh's fellow students, and they've come back to the college for their own private reunion.
Notice that everyone's wearing gowns. That was required in those days.
Those are our dinner gowns. Yeah.
You had to wear, at dinner you had to wear the gowns?
You had to wear dinner at gowns, yeah. There was a big fight about them.
Lucky you didn't have to wear the powdered wigs.
They were also convenient for an occasional sneaking in of a female.
Oh. So what's going on here? Bohr has come to give a lecture or something?
Yeah, he had come to give a lecture. So this is where talks would be given. This would be the place where Bohr would have given his talk that evening that he had the photograph from.
Yeah, I was sitting over in, I think, a soft seat here, and Bohr was sitting about here with a group of all the important physicists sitting around, plus Hale, I think, with their ears going like this, and I was just snoring over in the corner.
Yeah, but he was known to just talk very slowly and mumble and never quite finishes his sentences because he was thinking so deeply about getting everything right.
If Hugh's old pal Harvey had managed to stay awake, he may have learnt the world according to Bohr. Bohr proposed that everything be divided into two categories. Big stuff, like tennis balls, apples falling off trees, obeys the classical laws of physics. However, small stuff, about the size of atoms, obeys the crazy laws of quantum mechanics. Bohr didn't stop there. He described what happens when you look at something very tiny. At that exact moment, the particle stops behaving so weirdly. Instead of being in multiple quantum states, once observed, it's in just one state. It's now a nice, well-behaved little particle. The whole shebang was called the Copenhagen interpretation, and thanks to Bohr, became the established view. Oh, by the way, Copenhagen was Bohr's hometown. But the young and ambitious Hugh thought it was all most unlikely. How can just by looking at something affect the very behaviour of a physical object? Hugh was convinced that Bohr had it wrong, and so he decided to start on his own radical theory, helped on most evenings by a sherry or five.
Harvey?
Yes, please.
For a while, we had fairly regular sherry meetings before dinner. Very cheap sherry. Toast to Hugh.
Hugh, yeah. Great having a chance to
What are your memories of my father as a person back then?
He surprised me from the time I met him until I got to know him that he was as brilliant as he was. It didn't come across until you got close to him.
You think he was the smartest guy?
Well, he was smart in a very broad way.
Or do you think he thought he was the smartest guy?
Well, I think he did, but he didn't broadcast it.
Yeah, he didn't push it too much.
No, he certainly didn't around our house. I was not aware that he was like a genius physicist. I don't think ever, until like after he died.
That's interesting. Yeah.
Which room was my dad's?
Oh, it's the room up there with the open window.
Wow, that's like the penthouse. Did they put the smartest guys up at the top? Is that how it works? Or?
Yeah, probably.
Is that the room where he wrote his theory? Or,
Yeah, it must have been.
Oh, that's pretty exciting.
Yeah.
So what year would this have been when you lived here?
53?
1953?
That's right, yeah, 53 to 54.
Let's go into my father's bedroom. So if you lay in the bed in this room, it's said that you'll come up with crazy theories. This is exciting. Like in the music world, this would be like going to the Abbey Road studios or something.
Yeah.
Interestingly enough, I didn't inherit any of his mathematical genius. I have trouble adding up the tip at dinner.
I wonder what you feel you understand about your father's theory.
I understand that up to the point of anything that can be happening is happening somewhere. The somewhere part is the hard part to wrap my brain around, you know. We're becoming a science show now.
Yes, really bad.
A meeting with Max Tegmark, top physicist and Hugh devotee, is set to bend Mark's brain further out of shape.
It's a real honor to get to meet you, because your dad has just been such an inspiration to me.
Oh.
When I was a grad student in Berkeley, I found in this old bookstore a copy of this 137-page paper that your dad wrote, and it was like, wow. It suddenly all made sense. And since then, I've spent many years working on your dad's theory and various implications of it, and it's just so cool for me to actually get to meet you here and to even have a chance to help you understand.
Mark's father wasn't the only one who found Bohr's theory difficult to swallow. So did the physicist Erwin Schrödinger.
As Schrödinger himself pointed out in a famous article, that there's something really weird about this idea of dividing the world into two parts. Because, you know, you are made out of atoms. So if an atom can be in two places at once, so can you, right?
Schrödinger had devised an experiment to expose this absurdity. He came up with the most famous feline experiment in science, Schrödinger's cat. It goes like this. A cat is penned up in a steel chamber, along with a radioactive substance such as uranium, a Geiger counter attached to a quick-release hammer, and a flask of poisonous gas, hydrocyanic acid.
No.
Yeah.
He doesn't even have legs, and now you're going to poison him?
Don't blame me. Blame Schrödinger.
Schrödinger was never diabolical enough to do this for real. It was just a thought experiment. The heart of it all is a quantum event. Every now and then, completely randomly, there's a chance of a uranium atom decaying and emitting radiation. This radiation is enough to trigger the counter that sets off the hammer, breaks the vial that poisons the cat. But if none of the uranium atoms decay over the duration of the experiment, the cat will live.
What's so disturbing about this is the fate of a single atom, right, determines the fate of a cat.
According to the Copenhagen interpretation, until the experiment is observed by peering inside, the entire contents of the box exist in two possible states. Each uranium atom both has and has not decayed, and still further, the poisonous gas has both killed and not killed the cat. And this is the paradox. a single cat that is both dead and alive at the same time.